You use logical reasoning every day, but in geometry it's a little bit more formalized. So let's take a look at an example. If you did well on your tests, then you passed this class. If you drive too fast, then you will get a ticket. If you don't get enough sleep, then you will be tired. Another name for these if-then statements are called conditional statements. The statement following the if part is called the hypothesis, and the part following the then part is called the conclusion. So if I have this conditional statement, if you did well on your tests, then you pass this class, the portion following the if word, you did well on your tests, is the hypothesis, and the part following the then, you pass this class, is called the conclusion. What are the hypotheses and conclusions of this statement? You drive too fast is the hypothesis. You will get a ticket is the conclusion. You don't get enough sleep is the hypothesis. You will be tired is the conclusion. There are lots of different ways that we can write these conditional statements, and the easiest way to think about this is to use this chart. So, first of all, we have a conditional statement, and it's always in the form if something, then something else. So I've said if red, then blue. If we switch the red and the blue, or switch the hypothesis and the conclusion, it's called the converse. So that would be if blue, then red. We also have something called the inverse, which is if you put the word not in the conditional statement. So if not red, then not blue. We have something called the contrapositive, which is the opposite of the converse. So if not blue, then not red. And the last one is called the biconditional statement. And it's red if and only if blue. So let's take a look at some examples, but this is a good chart to kind of keep in front of you so that you have an idea of how these statements get put together. All right, let's take a look at some examples. So first of all, everything is built off of the conditional statement. So if red, then blue. The converse is when you switch the hypothesis and the conclusion. So if blue, then red. So if the converse, you simply interchange the hypothesis and the conclusion. So if your conditional statement is if you did well on your test, then you pass this class, the converse would be if you just switched those. If you pass this class, then you did well on your tests. When you determine whether a conditional statement is true or false, you are determining the statement's truth value. To show a statement is false, you need only one example, which we already know is called the counterexample, for which it is false. So, for instance, odd integers less than 10 are prime numbers. Well, let's think about our prime numbers. 1 is prime, 2 is prime, 3 is prime, so that's odd, but 2 is prime and it's not odd. 4 is even, 5 is odd and that is prime, 7 is odd, that's prime, but 9 is odd and it is not prime because 3 times 3 is 9. So there are counterexamples. 1 is kind of a weird number, it's not considered prime, but 9 is definitely also not prime and it is odd. So there's your counterexample. Are the truth values always the same for the conditional and the converse statements? Well, let's think about that. Let's look at this conditional statement. If it is Saturday, then it is not a school day. Well, that's true. Let's switch it and make a converse. If it is not a school day, then it is Saturday. Well, that's not necessarily true. It could be a Sunday, it could be a holiday, it could be a snow day. If you live in Canada, then you live in a country that borders the U.S. Well, that's true. If you live in a country that borders the U.S., then you live in Canada. Well, there are other countries that border the U.S., not just Canada. So when a conditional and its converse are both true, then you can combine them to make what is called a biconditional statement. And if you remember from our chart, a biconditional statement looks like red if and only if blue. So here's an example. Your conditional statement is if a polygon is a quadrilateral, then it has 4 sides. We'll switch it. If a polygon has 4 sides, then it is a quadrilateral. Well, those are both true. So since they are both true, I can write a biconditional statement that says a polygon is a quadrilateral if and only if it has 4 sides. But if one of these, if the converse is not true, then I cannot write a biconditional statement. All right, let's look at the inverse. So you can negate a conditional statement, which gives it the opposite meaning. So if your conditional statement is if red, then blue, your inverse is if not red, then not blue. So the opposite of a conditional statement is called the inverse. If an angle is a right angle, then its measure is 90 degrees. That's the conditional statement. If an angle is not a right angle, then its measure is not 90 degrees. That would be the inverse. We also have the contrapositive, which is the negate of the converse. So the opposite of the converse is called the contrapositive. So let's start with the conditional statement. If an angle is a right angle, then its measure is 90 degrees. Let's write the converse, which is switching the hypothesis and the conclusion. If the measure of an angle is 90 degrees, then it is a right angle. And now to write the contrapositive, we have to put the word not in there. If the measure of an angle is not 90 degrees, then it is not a right angle. All right, complete worksheet 2.2 and let us know if you have questions.